Now we're getting introduced to cosecant, secant, and cotangent. A quick reminder here. When we say the sine of theta, remember how it's y over r. When we say the cosine of theta, remember that it's x over r. And the let's try again. And the tangent of theta is y over x. So what we're going to do now is talk about cosecant, secant, and cotangent, and these are all just reciprocals of sine, cosine, and tangent. In fact, the cosecant, by the way, that's CSC for cosecant. The cosecant of theta is the reciprocal of sine. It's 1 over the sine of theta. And the secant of theta, is the reciprocal of cosine. So it's 1 over the cosine of theta. And the cotangent is the reciprocal of tangent. It's 1 over the tangent of theta. Now, we can also go back to this, because this will make it easier. Remember, cosecant is reciprocal of sine. In fact, it's just r over y. And the secant is reciprocal of cosine. It's r over x. And the cotangent is reciprocal of tangent. It's x over y. So this is what we're going to use as we go around and figure things out in the unit circle. So this first one is the cosecant, and our angle is 3 pi over 2. Notice that it's not written that way, but that's the same thing as 3 pi over 2, because the pi is over 1 and 3/2 pi. So what we're going to do is we're going to go clear around in the unit circle, and we're dealing with this point right here. Remember, in the unit circle that r is always equal to 1. So when we say r over y, our y at that point at 3 pi over 2 is -1. So in fact, what this is 1 over -1, r over y, and that of course is -1. For our next one, we're doing the secant of theta. Secant is r over x, so our r is always 1, so it's 1 over, and our x is 0. Well, we all know that you can't divide by 0. This is undefined. Now, in WMAP language, we write DNE for does not exist. The cotangent of theta is x over y. So x over y is 0 over -1, which is 0. Let's try an angle of 11 pi over 6. 11 pi over 6 is clear around in the unit circle right here. So the ordered pair is √3 over 2 and -1/2. Well, the cosecant is the reciprocal of sine. So the cosecant of 11/6 pi, or 11 pi over 6, it's r over y. R is 1. So 1 over y, 1 over -1/2. Now we're going to multiply by the reciprocal and flip that. 2 over -1. And that ends up being -2. The secant of 11 pi over 6, that's the reciprocal of cosine. It's r over x. So that's 1 over, our x is √3 over 2. So So this is 1 times, and we'll flip that, multiply by the reciprocal, 2 over root 3. But we're going to have to rationalize root 3 over root 3. So it's 2 root 3 over root 9, which is 3. The cotangent of 11 pi over 6 is reciprocal of tangent, so x over y. X is root 3 over 2. And y is negative 1/2. So that's root 3 over 2 times the reciprocal, 2 over negative 1. Those 2's cancel, and we get negative root 3. So 2 root 3 over 3 for the secant, and negative root 3 for the cotangent. Now I don't have a negative in here, I just noticed, so let's change this problem to negative 5/3 pi. And let's find the cosecant, secant, and cotangent. Well, notice that 5/3 pi, let's find that, 5/3 pi, that's clear around to here. It's 300 degrees. Now that's positive the way I drew it. We want to go 300 degrees the other direction. So negative angle, we start in standard position and go clear around. We're going to go 300 degrees, which means we are just 60 short. And we ended up right there at pi over 3. So our point is 1/2 and for x and root 3 over 2 for y. So let's give this a shot. The cosecant of negative 5 pi over 3. Cosecant is the reciprocal of sine, so it's r over y. And we know that in unit circle r is 1, so that's 1 over root 3 over 2. Well, we'll multiply by the reciprocal, so this is 1 times 2 over root 3. And we'll rationalize. So that's 2 root 3 over 3. The secant of negative 5 pi over 3 secant is the reciprocal of cosine, so it's r over x. R is 1, x is 1/2, so that's 1 times the reciprocal. That ends up being 2. And the cotangent of negative 5 pi over 3 is x over y. So x is 1/2 at that point, and y is root 3 over 2. This is 1/2 times the reciprocal. And we're going to have to rationalize. So it looks like it's root 3 over root 9 or root 3 over 3. These problems are really kind of the same thing. It's very helpful if you have a unit circle here. If you can't find one, I'll put a link on the classroom calendar. But if you can't find one, Google it, you will find one. But I'll put it on the classroom calendar for you. So let's look at this. It's pretty much the same thing we just did. So this first one, we're looking for the cotangent. And I know that the cotangent is the reciprocal of tangent. So the cotangent of pi over 2 is x over y. So I'm going to go here to pi over 2, and I'll do x over y. So the x is 0 at that point, and the y is 1, so that's 0. For this next one, we're going to do 3 pi over 2. So 3 pi over 2 is clear around to 270 degrees. And we know that the cotangent is, again, x over y. So the x is 0 at that point, and the y is negative 1. So again, we get 0. The cosecant of pi over 2, we're back to the point we were on just a second ago, right up here. So our point is 0, 1. So the cosecant is the reciprocal of sine. So it's r over y, and r is 1, and y at that point is 1, so we get 1. And apparently I just skipped one. The secant of pi, secant is the reciprocal of cosine, so it's r over x, and r is 1. Now we're at pi, right here in red, so it's 1 over x, 1 over negative 1, which is negative 1. Now, you did this kind of problem before with sine, cosine, and tangent. And this all goes back to remembering what angles look like in standard position. So remember in quadrant 1, the sine combination, x is positive and y is positive. In quadrant 2, x is negative and y is positive. In quadrant 3, x is negative and y is negative. And in quadrant 4, x is positive and y is negative. So this is what we need to do, along with remembering what each of these things are. The cotangent of any angle is the reciprocal of tangent, so it's x over y. The secant of theta, that's reciprocal of cosine, so it's r over x. And the cosecant of theta is the reciprocal of sine, so it's r over y. Now, as we look at these, we can use this information and the coordinate plane to figure out which one's positive and which one's negative. So let's start with cotangent. When is it positive? When is x over y positive? Well, x is positive in quadrants 1 and 4, and y is positive in quadrants 1 and 2. So I want to make x over y positive. I want both x and y to be positive, or both x and y to be negative. So in quadrant 1, both x and y are positive, so this is quadrant 1. And in quadrant 3, they're both negative. And if x is negative and y is negative, a negative divided by negative is a positive. So this is quadrant 1 and 3. The secant is positive. Secant, again, is r over x. So we know r is always 1 every single time, positive 1. So all we need to do is look at x then. So where is x positive? X is positive in quadrant 1 and 4. Secant is negative. Well, again, r is positive. X is all we need to look at then. So where is x negative? X is negative in quadrants 2 and 3. Cosecant is positive. Cosecant is r over y. R is 1, always positive 1. So where is y positive? That would be quadrants 1 and 2. Where is cosecant negative? Cosecant is r over y. R is always positive, so where's y negative? In quadrants 3 and 4. And the last one here, cotangent. Where's cotangent negative? Cotangent is x over y. So I want either one of either x or y to be negative, not both, because that would make a positive. So where is x negative and y positive? Where is x positive and y negative? Well, that would be in quadrants 3 and 4.